Hello, everyone. We're gonna delay the first keynote by maybe 15-20 minutes. Something like that, because apparently it's our first PyCon. We didn't know that people like to sleep. Znači može na 15 minuta sve se produži tako. Okay, can everybody grab their seats slowly? Can we close the doors maybe as well? And can we get the people who are from outside also in, because we're gonna start? Okay, one more door to close. Okay, hello everybody. Welcome to day 2 of PyCon. Our keynote for today is going to be the person who spends
there. I'd like to thank Bojan and Odd and the rest of the PyCon Balkan team for inviting me to speak here today. I've had the opportunity to speak to pieces of the Python community all over the world. But no matter where it is, it's an absolute honor to be able to add another pin to my map up there. Firstly, who am I anyway? Well, in my day job, I am a senior data engineer at Savata. We're a market research company. We use Python and data science to help brands to understand their customers. They give me the flexibility to attend conferences like this one, for which I'm extremely thankful. But if you've heard my name before, it may be because I've been a member of the Django core team for almost 13 years now. I was president of the Django Software Foundation from 2010 to 2015. I served on the Django Technical Review Board for the 1.7 through 1.11 releases. Django is a big part of the Python ecosystem, but it's by no means the only part. Django isn't the only Python web framework, and web programming isn't the only thing people do with Python. In my current day job at Savata, I don't use Django at all. I do, however, make extensive use of NumPy and Pandas and the ecosystem of tools around those libraries. And there are many other uses of Python. There are other Python web frameworks. There are other numerical processing and statistical analysis tools. There are projects for using Python on embedded devices. There are libraries for performing astronomical calculations and biotech and gene sequencing. It's used as a scripting language for operating system automation. It's used as a teaching language. None of this happened overnight. Python as a language is 25 years old. It took maybe 10 years for Python to gain any sort of significant traction in our industry, and it took another 10 before it really gained widespread support. But that persistence is paying off. In September of last year, Stack Overflow published a blog post talking about the huge growth of popularity of Python. Python is the red line on that chart. JavaScript is the yellow line at the top with fairly modest growth. The other languages, Java, C#, PHP, C++, they're all fairly static. The growth that Python has shown here is impressive. Interest in Python almost tripled over the 6 years that's being measured here. And that's not, we went from 1 user to 3, so we've had 300% market growth. That's working from a starting point of a market the same size as PHP and C++. Stack Overflow's projection last year was that this growth curve wasn't about to flatten out, that we're still in the growth phase. And the Stack Overflow numbers are backed up by other sources. In September of this year, Python became the #3 language on the TIOBE index, which is a measure of programming language popularity. Python jumped 2 places in the last year. It's also worth noting where other popular languages fall on this list. JavaScript is at 7, Ruby is at 12, Swift is at 15, Go is at 16, Rust is at 31. Now, these are metrics, and they are popularity metrics at that. They are not objective measures of truth. These numbers don't mean that Python is the best language or that other languages are rubbish. The idea that you can reduce the entire programming landscape to a single popularity metric is laughable. But metrics like this do serve as an interesting starting point for a larger discussion. Let's take a look at that TIOBE index again. Notice the languages that are on top, Java and C. Notice the languages immediately below Python, C++, Visual Basic.NET, PHP. They're not the hot languages that set Hacker News abuzz, but they are languages that are going to be with us for a long time. For me, what's remarkable about Python's success is that it achieved its current level of popularity without being officially supported or blessed anywhere. Python isn't installed by default on Windows, and it's only very recently you could use Python on Windows without spelunking in the registry. Python is installed by default on macOS, but it's Python 2.7 and the install is usually broken in some really subtle way. And Apple isn't showing any signs of keeping up with the Python community and upgrading that default to Python 3. So Python isn't popular by default. It's not popular because it's just there. C was and still is the default legacy language for cross-platform systems programming. C++ and as sort of built on that. Java is the default platform for enterprise. C# and Visual Basic are Microsoft's chosen platforms for systems and user code. But Python, it's still a young language, but it's not owned by any one company. No single company dominates or controls the platform in the same way that Oracle controls Java or Microsoft controls C#. And that's a significant advantage. It means we're not beholden to the interests of any one corporate master. But the advantage is also a problem. Just as we're reaching this point of popularity, the market is changing, and we don't have a large player making our case. When Python emerged as a language, a computer was a large box that sat on your desk or maybe in a server room. Over time, the boxes got smaller, you started carrying it around in your backpack, but you still use the same operating system, Windows or some sort of Unix derivative. Over the last 10 years, we've seen the emergence of a whole new class of computing devices, much smaller, often portable, things like phones and tablets and watches and set-top boxes. And we've seen the emergence of the web browser as a computing platform in its own right. But you can't use Python on any of those platforms. Never mind that it's hard to get Python going on Windows or Mac for the first time. You can't install Python at all on an Android or iOS device or in the browser. These devices are becoming ubiquitous and they're replacing laptops. My son started high school this year. He doesn't have a laptop. He has an iPad. Phones and tablets are achieving market penetration that desktops and laptops have never seen. The vendors of desktop operating systems are all working out how to transition their existing software offerings into this new space. Windows is pushing the idea of the universal Windows platform, placing an increasing focus on mobile and touch platforms. Apple has just announced Marzipan, a framework specifically designed to bring mobile and desktop APIs to parity, making it easier for iOS applications to be sold as laptop apps. Google is modifying Chrome OS to allow Android applications to run on their desktop operating system. All of the operating system vendors are positioning themselves for a world where laptops either don't exist or they are niche devices. And at the same time, vendors are changing the way they look at programming languages. On desktop platforms, Windows, Linux, macOS, you're free to use whatever programming language you want. Okay, sure, there are preferred languages on each platform, but you can install other language runtimes and those languages can target the installer tooling for those platforms. This isn't true on mobile platforms. All of the mobile vendors are pushing very specific ecosystems. Windows wants you to use .NET. Google wants you to use Java and Kotlin. Apple wants you to use Swift. The platform tooling only supports one language. Installation is almost always through an app store. These changes have been hugely beneficial for the vendors. Walled gardens are great for revenue. But if you want to use something outside those blessed languages and tooling, you are on your own. The flip side of Python's independence from corporate masters is that there isn't a corporate master making a whole for Python. And as a result, Python isn't a solution that is available in this new worldview. I think we need to start looking very seriously to the future and ask what role we see Python having in that future. If we're intending Python's success to continue, how are we going to maintain and grow our market when the devices people are buying can't run Python? What is the future of Python? The existence of this platform trend is one of the reasons why I changed the focus of my open source contributions a few years ago. I developed a reputation working on Django and web frameworks. These days, I'm spending most of my volunteer time on the Beware project. For those who haven't come across it before, Beware is a collection of open source tools and libraries for creating native user app interfaces in Python for desktop, but also for iOS, for Android, single page web apps, and other new hardware platforms. And a key part of that work is getting Python to run on phones and tablets at all. Now, this is a big project. I've got lots of stickers if you want them. I have been working on Beware for years, and there are days where I really do feel like the mythical Sisyphus pushing his boulder up that great big hill. So why bother? Well, okay, yeah, it is a big task, but I think this is also a huge opportunity for Python. Right now, if you want to write a mobile application, you have to write it twice. You have to write it for iOS, and you have to write it again for Android. Personally, I think we are more likely to see Satan ice skate to work before Google supports Swift on Android or Apple supports Java on iOS. It is simply not in their commercial interests to allow developers to easily support the competition. So if you want to write an application that can be used by everyone, you need a cross-platform solution. Now, okay, you could maybe write your application as a web application, and a lot of apps really should just be mobile-enabled web pages. But there are things you can't do with a web page. Good operating system level integration with phone features like cameras and GPS, accelerometers, for example. Even basic things like device level persistence and state management can be a real pain to work with in the web. You can work around some of these limitations with things like PhoneGap and other web bridging frameworks, but I am yet to see a web-based application that offers an end-user experience, either as a developer or as a user, that's even vaguely comparable with an actual native application. And the market that needs the ability to write these cross-platform applications is also the market where Python has an existing advantage. Python is big in education. It's big as a language to introduce people, especially children, to programming. Teachers want to engage their students, and a great way to do that, let them write applications they can run on their phones. Python is also big in scientific disciplines, a demographic that is smart and capable, but motivated by what they're studying, not by programming. They just want the damn thing to work. And they've got a huge body of domain-specific tooling that is grounded in the Python ecosystem. They can't just abandon that part of the ecosystem. These markets are already using Python. All they're missing is the tools to use it on mobile. And that means there's a window of opportunity here. Python could be the language that allows this part of the market to write mobile applications. There will always be a need for native iOS, native Android programmers writing professional iOS and Android apps. I'm talking about the long tail of application development here, the scientists, the students, the prototypers. Python could be the language for getting things done on mobile programming, in the same way that it's a language for getting things done on desktop platforms. And for exactly the same reasons. It's a language that is accessible to newcomers, but powerful enough to scale for heavy lifting purposes with an ecosystem of tools and a user base that's growing. But this user base is going to disappear if we don't come up with a story for Python on mobile. There are already cross-platform toolkits in other programming languages. So we are fighting against capabilities that exist elsewhere. If other languages develop a better education story or better scientific support libraries before Python develops a mobile capability, this is a market we are in a position to lose. My personal aim is to make Python as simple for the developing native apps as Django makes web development. And we've still got a way to go before that is true, but I do think it's possible and it's not even that far-fetched. However, there are some impediments in our way. One of the biggest stems from the focus of the Python core team itself. Now, to explain what I mean by this, I've got to pose a question. I'll come back to this question a couple of times in this presentation. What is Python? Well, conceptually, Python is a programming language we all know and love. But in practice, from a technical perspective, it means, first and foremost, CPython, the de facto reference implementation of Python that runs primarily on a Unix-like operating system. And in a world that's dominated by servers and laptops that expose a Unix interface, that answer's great. It's actually even fine for iOS devices, for all the layers that Apple puts on top. If you squint enough, iOS is a Unix. You can compile CPython for iOS and you can write Python code that deploys on iOS without too much difficulty. But there's a difference between something being possible and something being officially supported by the Python project. It's possible to build CPython on iOS. I know because I've written a bunch of scripts to do just that. But it's not something that's available out of the box. You can't download an installer from python.org. It would be nice if this was something that I didn't have to maintain externally. Now, I did submit a patch to the CPython team to do just that. But engaging the core team around this issue hasn't been especially productive. To be fair, this is significantly on me. I haven't been pushing this issue that hard. I submitted a patch a couple of years ago. At the time, some legitimate high-level project management questions were raised, and I haven't pushed to get answers to those questions. But part of the reason I didn't pursue it that vigorously was that the level of engagement that I've seen around this problem was indicative to me that the CPython core team either didn't see this as a major problem that needed to be addressed or didn't have the resources to address it at the time. And as a result, I haven't put a lot of my personal resources in pushing this particular boulder up that particular hill. What I have right now works for my immediate needs. If that changes, I may do more to engage the Python core team. What is more concerning to me is that this isn't just a problem that I have, and it isn't specific to mobile devices either. For many, many years, the installation story for Python on Windows was abysmal. Windows as a platform just didn't get attention. There was an installer, but you needed to do a whole bunch of manual tweaking before anything worked. And the Python execution story assumed that script execution on Windows would work the same way as it did on Unix, and it just doesn't. It wasn't until Mark Hammond took on this problem as a project a couple of years ago that anything got fixed. The problem also manifests in API design, when the Unix support layer for Windows. It has changed recently, it's gotten a lot better in recent years, but the native Windows API and event model is fundamentally different to POSIX. In the implementation of the banner feature of Python 3.4, async IO, is very tightly bound to the Unix event and socket model. In theory, sure, it's got an API with base classes and a Unix-specific implementation, but the design of that base class almost assumes the implementation will be Unix. That means integrating the async IO event loop with native event loops is relatively easy on Unix and macOS and iOS, but on Windows, it's hard. There's a fundamental design disconnect. The problem also exists when you look at Python being more than just CPython. When we say the Python core team, it's easy to think of that as a language specification team, but it usually effectively implies CPython as an implementation. But there are other implementations of the language spec, Jython, IronPython, PyPy, and many others. And if you're working on an alternate implementation of Python that doesn't use C, the C focus of the Python core team can be a problem. Maciej Fialkowski is a member of the PyPy core team, the JIT-optimized Python interpreter. He recently tweeted, "My prediction, inability for Python community, especially numerics, to support multiple faster runtimes will lead to the decline of Python in scientific computing somewhere in the future. To clarify what I mean, the reliance on CPython CAPI, which exposes interpreter internals, is a major impediment against all other implementations, real or hypothetical." So, in the opinion of someone well-versed to speak about high-performance computing, the focus and approach of the CPython core team could lead to the decline of one of the very communities that has been a major contributor to Python's success. In my opinion, what we're hitting here is a fundamental problem with the way Python is developed. It's reactive, not proactive. If you took a poll of the Python core team and asked, is it important for Python to work well on Windows? I would be willing to bet that every single one of them would say yes. But if you ask the same developers, are you personally motivated to make Python work better on Windows? The answer would almost certainly be no, except maybe for Brett Cannon, Steve Dower, Eric Snow, Dino Veland, the members of the core team that work for Microsoft, and even those responses would likely be qualified by whether Microsoft was paying them to work on Windows integration. The development process of Python is primarily reactive, not proactive. It tends towards addressing immediate problems that exist right now or that directly serve the current interests of the employers that are paying for contributions to Python. It's a lot less effective at addressing strategic problems that we might foresee. Free and open source projects like to talk about contributions being driven by people scratching their own itches, that people use a project, find a problem or limitation, and then they resolve those issues by contributing code to fill the gap or fix the problem. Scratching itches is a good way to rationalize why someone will fix a specific bug or add a small feature that adds on to existing frameworks. But it doesn't explain how you ensure that strategic, long-term, forward-looking plans are made and explored. Sometimes fixing a problem requires a significant chunk of time for a redesign or a refactor. How do you find that time? It takes a lot of discipline to put aside what you personally find interesting or compelling so that the long-term interests of a project are looked after. It takes a lot of effort to convince your boss to fund an engineering activity that has a long-term payoff for someone else. When Google or Dropbox hires Guido, they do primarily to ensure that a tool they are currently using continues to be useful. Any new or novel applications of Python, applications that expand Python's reach or usefulness, those are of secondary interest. And what happens when you know you've got an itch, but you don't have the skills to scratch that itch? It's really difficult to fix problems on Windows if you don't own a Windows laptop, or you're not sufficiently familiar with the Windows ecosystem to judge whether something works the way a Windows native user would expect. What happens when you don't even realize you have an itch? When, because of your lack of training in a particular area, you don't even realize that this thing that keeps happening, this group of people that can't use your code, is a problem that needs to be and can be resolved. The current Python core team is primarily driven by the needs of the CPython implementation. And in the desktop-driven world, that's what most people mean when they say Python. But it can't be true of Python going forward because CPython just isn't an option on many of the platforms of interest in the future. So what's going to cause the Python core team to change their development focus? And I want to be very, very clear here. I don't say these things as an accusation or as blame. The Python core team is doing the absolute best they can with the resources they have. I raise these issues as something that I, as a user of Python outside the core team, perceive as a strategic risk to Python as a whole. I raise them as issues that I see as an impediment to progress in my own projects and where I see the future of Python heading. I want Python to survive and thrive, but I also know this is a goal shared by the Python core team. I may have disagreements with the core team about what is most important right now or how to best achieve the things that we agree are important. But I will not for a second doubt that the many people who work on Python, from Guido all the way down, do what they do with the best of intentions. Unfortunately, it isn't always obvious that everyone understands this. Let's come back to this foundational question. What is Python? Is this Python? Well, okay, sure, it's just an if statement. There's nothing really controversial there. What about this? Is this Python? Well, no. At least it hasn't always been. Boolean wasn't a type until Python 2.3. It was added in PEP 285. In Python 2.2, true and false were numerical constants. In Python 2.1, true and false didn't even exist. Is this Python? Again, not always. Context managers were added in Python 2.4, it's PEP 343. When I started working on Django in 2006, we couldn't use context managers because Python 2.4 had only just come out and Python 2.3 was what was available on most common versions of Linux. So this isn't ancient history. This is my recent working memory. What about conditional expressions? Again, not always. It was PEP 308. It was added in Python 2.5. Prior to Python 2.5, you had to use what was called the and/or hack. It relies upon the different order of evaluation of Boolean statements to produce the same result as what is now known as a conditional expression. Same outcome, but less legible and prone to some interesting edge cases that I'll leave as an exercise for the reader. Is this Python? Only very recently, f-strings were added in Python 3.6 as part of PEP 498. In Python 2, you had to use C-style printf substitution. In Python 3, they added the format function. And in Python 3.6, they added f-strings. Is this Python? Not quite yet. Simon expressions, I prefer the name the walrus operator, cuckoo cuckoo. That's going to arrive in Python 3.8 as part of PEP 572. The walrus was added as a shortcut for a common usage pattern where you call a function and then only handle the return value if the return value is truthy. Now, this is especially useful in loops because you don't have to duplicate the logic getting the object that you're looping over. Why did the core team make these changes to the language? Because they wanted the language to get better. They see patterns of usage that they think can be simplified. The with statement is a pattern of usage around files and threads and other objects that have an enter context, do work, leave context life cycle. They see patterns of usage that are prone to bugs. The and/or hack is exactly that, a hack. It's got all sorts of landmines hidden in it. And they do this with the perspective of a group that is paying close attention to how the language is being used and abused in the real world. You may have noticed that something you're responsible for gets a lot more of your attention than it would otherwise. If you are working on a product, you see all of the little tiny bugs and defects that no average users just don't see. The Python core team sees this with Python, and they have considerable experience in this field. The problem: every single one of those proposals that I just showed you was met with distaste, derision, and in some cases, outright hatred on Python mailing lists. Some of these problems, some of these changes are now so embedded in the culture of Python, I can't imagine a Python without them. Or in some cases, I can remember, and then I shudder, and I start thinking about puppies and kittens to make the bad thoughts go away. I can't imagine using Python without a Boolean type. I can't imagine going back to Python that didn't have conditional expressions and context managers. I am on record saying that I was very skeptical about f-strings, but having used them, I think I like them. I miss not being able to use them in code bases that need to work on Python 3.5 and earlier. So fulfilling a promise I once made to Marietta, Marietta, you were right, you told me so. Reasonable people can disagree about whether changes to Python are good or bad. But reasonable people don't have to be assholes when they disagree. And that's what happened with PEP 572, the walrus operator. The aftermath of the decision to approve PEP 572 was bad. Really, really bad. So bad that Guido resigned as BDFL. We, as a community, broke Guido. And okay, he did say in his resignation email that it wasn't just about that PEP. He's reducing the bus factor, acknowledging that he's not getting any younger. But a key factor was the backlash against him accepting a PEP. And that was a PEP that had been in discussion in public, that had been formally under discussion for 6 months and informally for longer. And yet when the PEP landed at the end of that long debate, that was when people came out of the woodwork to pile on about how Guido was destroying Python. We took someone who has dedicated 25 years of his life to making our professional lives better, and we broke him. If that doesn't give you pause to reflect on everything you've ever said online, how you've said it, how you've expressed dissent, then frankly, you need a wake-up call. I, luckily, have never had to deal with the sort of hatred that Guido received, but I have been a part of online communities for 30 years. I've been a maintainer of online communities for almost 15. And I'm here to tell you, dealing with people is emotionally exhausting. The sense of entitlement that some people seem to have around something they've received at no cost with no obligation to give back in any way is genuinely phenomenal. And over time, those pressures add up. My personal experience, I was diagnosed as being in the middle of a major depressive episode in 2016. And as with Guido's case, there were a number of contributing factors, but one of the big ones was the pressures imposed by my volunteer work dealing with the Django community, in particular dealing with code of conduct issues, and one code of conduct issue in particular. I burned out on the Django community. I'm still part of that community, but I don't actively contribute anywhere near as much as I once did. I fully expect that the Python core team will continue to add new features to the language or make small changes to the way it operates. If Python ever stops changing, I imagine that will be a signal that the language itself is dying. And as the core team contemplates new proposals, they're going to have to weigh up the benefits and consequences of the changes they're proposing. Language design is an art, and the worst thing is there's no right or wrong answers. There's just a series of compromises. I know the Python core team doesn't rush into anything. They know the magnitude of the thing that they are responsible for, and they've got enough breadth of experience on the team and enough of a track record of careful consideration. I think we can trust their judgment. The problem of which features to add or not to add to the language, how to support or not support Windows or mobile platforms, these are technical questions. As a community, we're going to continue to have discussions about async handling and syntax additions and other technical questions. But they are fundamentally solvable technical questions. I certainly have opinions about how some of them can or should be solved, but more importantly, I have confidence that the core team and the rest of the Python community can address them. The thing is, the hard problems faced by any community aren't technical. The hard problems are human problems, social problems, community problems. I certainly hope we don't ever see a repeat of PEP 572 ever again. People need to be able to express their concerns, but I don't want to see a debate that contributes to someone walking away from a project because of the sheer volume of vitriol that they had to bear. Guido's departure has forced us to face maybe the biggest community problem you can face, that of governance. How do we replace a BDFL? And if we're considering the future of Python, how that future will be governed is a big part of that question. Which, once again, brings me back to the question that I've asked. What is Python? For me, the most interesting answer is that more than anything, Python is a community. There's an almost cliched quote that gets bounced around. It's attributed to Brett Cannon: "I came for the language, I stayed for the community." Now, Brett claims that others have said something or very similar things around the same time. But regardless of the provenance, it's a lovely statement. But in order to survive, a community has to be healthy. Everyone needs to feel that their views are being heard, that their concerns are being addressed, that their fears aren't being exploited. Everyone needs to feel like their contributions are welcome. They need to be enabled to actually contribute. They need to be respected while they contribute. It's true of civil society as much as it is of a software community. If we're expecting to grow as a community, we need to make sure these problems don't grow as well, or worse, amplify and get worse. My opinion here, we have a bit of a problem, and it stems from how our community supports itself. Who is actually doing the work here? What we see today as the Python community is the result of countless thousands of hours of largely volunteered effort. And being primarily software engineers, the question that gets the most immediate attention is who is going to write the software? You know, writing software takes a lot of effort. Doing it well takes time and skill. But that's only considering the code. Any project, especially one the size of Python, is so much more than the code. Project and team management is a skill. Too often we assume that good engineers will somehow automatically transition into being good managers. It's just not true. Who does graphic and interface design work for a project? Designing a good website is a skill. Your average open source project website will show you that most engineers do not have that skill. Developer relations is a skill. DevRel is a role that extroverted engineers sometimes fall into, but it's a distinct set of skills, mostly related to effective technical communication. And speaking of communication, who writes the documentation? Technical writing is a skill. It's a skill that most engineers should practice a lot more than they do. But those are all skills that could be broadly considered in the remit of a well-rounded software engineer. What about the things that aren't even remotely software related? Who organises community events? I know very few engineers who aspire to be professional event organisers. What about legal advice? Who advises on license or trademark law? Who writes cease and desist letters? Who provides advice on slander and libel in blog posts? What about public relations? Who writes the press release when a new version of Python's released? Who makes sure the wider community is aware of the decisions that are being made by project leaders so that the big decisions don't come as a shock? Who does the fundraising? Who builds the relationships with large potential donors? Who builds relationships with philanthropic and government groups that offer grants? Who writes the grant applications? When Microsoft or Google or Heroku or GitHub or whoever's about to launch a big new product, who makes the strategic deal with them to make sure Python is a supported language from day one? It turns out there are people in the world who can't program, who have remarkable skills that are very, very useful. If a lawyer announced that they were going to write their own clone of Google, you could bet every engineer who heard the story would laugh. Yet somehow we expect open source projects to provide their own legal advice. I don't for a second want to discount the incredible efforts that volunteers have put into Python and other open source communities, but there are things that are done better if you have someone whose job it is to look after those things and whose training has prepared them to do those things. And if you find people who have expertise, they can use that expertise to help you. However, these experts, they kind of expect to get paid. From inside the bubble of open source software development, it's easy to lose sight of the fact that some of the cultural norms we see aren't normal in any other industry. Open source software is the only industry where it's apparently expected that having worked your 9-to-5 day job doing something you're skilled at, you'll go home and do some more for free and encourage multi-million-dollar organizations to benefit from your efforts. In most industries, if you're good at something, you get paid to do it. And people outside of software have really useful skills. Design, legal advice, event planning, fundraising. These are all very useful skills and skills that most open source projects badly need. But it's true of the software industry as well. People are paid to write software. And there's plenty of software that should be written, but isn't, or isn't written in a timely fashion because we're waiting for volunteers to do the job. Django is a web framework, and it took the DSF over 3 years to coordinate the most recent redesign of its website. Why? Because if you need volunteers, you're immediately constraining the amount of time and effort that anyone can put into the job. If you pay them, that problem goes away. More importantly, what opportunities have we left on the table because we didn't resource them adequately? What constraints have we placed on our own growth because nobody was enthusiastic enough to volunteer their time to address some gap or make the most of some opportunity? Who have we excluded from the development process because they couldn't justify donating all of their spare time to a volunteer effort? And as our need for these expert skills and resources is only going to increase. If our community is going to keep growing, we're going to need more project and community management, more legal advice, more event organisation, and more software development. And this isn't just about finding out how to resource the things that we're going to need as we grow. It's about how to mitigate the not insignificant costs we're already incurring. I've already mentioned 2 people, Guido and myself, who have burned out on some aspect of contributing to this community. I can think of dozens of others who have had very similar experiences. Are we, as a community, comfortable that we are doing this to our peers, to our leaders, or to anyone for that matter? Do we want to build our industry and community on the expectation that volunteers in our community will give of themselves until they burn out? Or do we want to find a way to make sure that people who are able to do good work in the community have the resources to do what they do well and access to individuals with skills in other areas? This, unfortunately, brings up an uncomfortable question for the Python community and more broadly, free and open source software communities. I've been saying resources here, but let's be clear, what we're really talking about is money. People aren't resources. Their labour is a resource, and in a fair economy, it's a resource that needs to be paid for. But if someone is going to be paid, someone needs to be doing the paying. The messy question of free and open source is who pays? Whose responsibility is it to shoulder the burden of the work that needs to be done? What do they pay for? And how do they pay? It's not just enough to throw out your hat for donations because that mode of payment doesn't fit into the accounting structures of most large organisations. If you want to extract money from a large organisation, you have to structure your ask in a way that's compatible with their accounting needs. How do we do this? Funding open source projects is a talk unto itself, one that I have given elsewhere. Unfortunately, I have never found a good answer. If there were good answers, the PSF and the DSF would be well-funded institutions, not volunteer organisations run on a relative shoestring budget. One recent discovery I've made is that this is actually an area of academic economics research. Elinor Ostrom won the 2009 Nobel Prize for Economics for her study of what economics calls common pool resources, or CPRs. Real-world examples of CPRs are things like forests, or grazing lands, or fishing grounds, or irrigation channels, but open source fits this same mould. There are situations where anyone can access the resource. The best individual strategy for using the resource is to take as much as you can get. But the best communal strategy is to limit what you take and contribute back to maintaining the resource so that in the long run, the health and productivity of the resource is also maximised. Ostrom's work looked at examples of common pool resources that are being managed in the real world and successfully. Some of them, grazing and forestry rights in Switzerland and Japan, huerta irrigation institutions in eastern Spain, they have been collectively operated and maintained for hundreds of years. Now, I don't know if the research on CPRs can be adapted for open source, but I think it's definitely an area that's worth exploring. If we do, we may have to face some unpleasant facts about who we allow to participate in our communities and on what terms, and in some cases, who we exclude from our communities. But we can't ignore the problem. Anyone paying attention can see the repeated patterns. I have seen projects flounder because the maintainers can't get enough clear air to do essential maintenance or to address a strategic gap. I have seen projects fail to reach their potential or take far too long because they can't attract the volunteers that they need. And I've seen too many open source contributors burn out from the workload that's imposed by volunteer work. We have these problems at the level of Python. We see them at the scale of large projects in the Python ecosystem like Django. We see them in smaller projects in the Python and Django ecosystem. And we see them with emerging projects like Beware. What is most concerning to me is that when projects do try to address these problems, they get lambasted for it. Redis Labs recently announced a licensing change to some of their plugin modules. They didn't even change the license on the core of Redis. It is and remains BSD licensed, but they changed the license on some of their modules from AGPL to Apache with a new Commons clause. The intention of this change, stated intention of this change, was to address a key problem, that Redis Labs was putting in the majority of development effort into Redis, but hosting companies like Amazon, Heroku, and Rackspace were making all the money. And none of that money is being put back into the development of Redis. The uproar around this licensing change was incredible. And okay, legitimate complaints can be made. But what's most concerning for me is that in all that pushback, especially from free software advocates, there was very little recognition of the key point that led to the decision that Redis Labs have a legitimate complaint. They are being exploited to the tune of millions of dollars by hosting providers. And the existing free software solutions like the AGPL do not address the problem. What worries me is that the zealotry around free and open source principles is standing in the way of a much needed debate about how we manage and provide the resources for the tools and communities that are vital for our existence as an industry. The open source and especially the free software community is very keen to talk about the freedoms that we must have in writing software. And I completely agree that those freedoms are important. But let me ask this, what price is too high? If free software principles induces or encourages people to burn out, is that acceptable? If there isn't equity of access to the development process, if these institutions around free software systematically prevent minorities from engaging in those communities, what is the point of having the freedom in the first place? In his 1918 essay, Politics as a Vocation, the moral philosopher Max Weber wrote about two fundamentally opposed ways to evaluate ethical systems. There's the ethic of ultimate ends and the ethic of responsibility. The ethic of ultimate ends says that you should always do what you perceive to be the right thing regardless of consequences, that doing right will ultimately lead to the right outcome. The ethic of responsibility says that you have to give an account to the foreseeable results of your actions when determining what you should do. To date, the free software movement has been conducted almost entirely within an ethic of ultimate ends. The consequences we are seeing in our community today exist because of that. Everything that is done must be done in the service of software freedom, regardless of consequences. The movement is so fixated on software freedom as an ultimate end that they've ignored or silenced any discussion about the broader problems that that problem causes. I think we need to give a lot more consideration to the ethic of responsibility in our discussion about software freedom. So, what is to be done? Well, okay, here's my calls to action. My first call to action, start thinking and talking about where Python is going. Not the minutiae of individual PEPs, the big picture about how and where we're using Python, where we could be using Python, where we should be using Python, and more importantly, where we can't use Python. If we turn around in 5 years and discover that Python usage is dropping because nobody has a device that can run Python, or because Python doesn't solve problems that people actually have anymore, we'll have no one to blame but ourselves. We can all see what's happening in our industry. We need to make strategic plans for that future. We need to factor those strategic plans into how we manage our community, or the future will swallow us whole. Secondly, In the absence of a good structure to support open source software development, we've got to work with what we've got. When you go back to your place of work on Monday, to work at a company that's using Python or any other open source project for that matter, projects that are vital parts of your infrastructure, tell your manager they need to get out their king wallets. Get them to donate to the governing organizations that manage the projects you use. And not just a once-off $100 donation either. Try to get them to make substantial, regular, ongoing donations, something reflective of the extent to which open source software is used by your organization. Hot tip, the Python Software Foundation has a fundraising drive going right now, and it's been going for a while, and frankly, the donation levels are pitiful. Having said that, I know from experience that this isn't an easy conversation to have with your manager. My advice to you, reframe the discussion. Although technically, what the PSF and other organizations are asking for is a donation. What you are doing as an organization is managing risk. If you are a commercial organization who depends on a project like Python for your livelihood, and you aren't taking steps to contribute to that project, I would argue you are being criminally negligent to your investors because you haven't secured your supply chain. You haven't mitigated a key risk associated with your technology stack. If you use Python and you aren't funding the maintenance of Python, what is your company's plan to resource rewriting your entire stack because using Python is no longer tenable because the stream of volunteers has dried up? Investing a small amount of money now is a hedge against future catastrophe. My last call to action is a longer term one. As a community, we need to start talking about our community's relationship with money, or more generally, how we provide the resources to develop the software that we are all using. As a community, we have not established the conditions where companies are readily able to contribute. We haven't provided the conditions that make it clear that donating money to the PSF or any other organisation will in fact mitigate strategic risk. We haven't provided the conditions that enable organisations to pay and to structure that payment in a way that is compatible with their accounting needs. And we haven't set up the structures that enable our communities to use that money when it's available. It's not just enough to need money, we actually have to rethink what we're providing, the way we're providing it, and how we structure that in a way that is palatable to those that are going to pay for it. I am not saying for a second that volunteer development or volunteer contributions should be eliminated from the process. The fact that anyone can get involved is a key part of the open source ethos, and we should not lose sight of that. But there are jobs like project management and public relations and large-scale strategic development that need to be funded way better than they are at present. 9 women can't make a baby in 1 month. Sometimes a job requires the prolonged and focused attention of a single person. It can't be squeezed into weekend and volunteer time. It needs dedicated, full-time resources, and that means funding people. And in case you weren't a believer, we have had some very recent demonstrations that show that money makes things happen. PyPI, the Python Package Index, has been around for 15 years. It has badly needed a rewrite for almost half of that time, but the work never got finished. Why? It was clearly needed, but nobody was being paid to work on it. Then Mozilla gave the PSF a grant of $170,000 and the work was done in 6 months. Why? Because that money enabled a couple of people to focus on getting the job done instead of trying to fit bug fixes in on weekends between their kids' football games. Money isn't everything, but money is a very, very useful thing. We need to start having conversations about how we're going to provide those resources. And there is an unexpected benefit to that. It broadens the list of people who can do the work. Volunteers, by definition, are made up by those who have the time to volunteer. If you have family or children or loved ones that need care, those commitments take priority, as well they should, and they limit your ability to volunteer. You want to address diversity in your community? Make sure that you're not just taking volunteers from the pool of people who have copious free time, which, broadly speaking, means white, middle to upper class men aged 16 to 30. So, what does the future hold for Python? I have outlined what I see as the threats and opportunities, but I'm just one guy. I'm from Australia, feel free to ignore my opinions. But I know that if we want Python to continue to be a force in the world of computing, we can't stand still. We need to prepare for the ways computing platforms are changing. We need to make sure that our communities are healthy and diverse and respectful and vibrant places where everyone can collaborate. We need to make sure that our strategic goals can be addressed. Personally, I intend to keep working on Beware, my umbrella project covering the tools to get Python going on new computing platforms like phones and tablets. I'd like to think I'm not alone in wanting this, but Honestly, without some sort of external financial support, it's going to continue to be a hobby project, and without more substantial engagement from the Python community, it's going to take forever to reach a point where it's a viable option for using Python on mobile. If you've got any good ideas for how to fund this development work, my email inbox is open. I'm here till Monday, come see me. Or if you'd just like to help out, we're always looking for contributors. But I know one thing, I'm not one to shy away from the challenge. Reaching once again for Max Weber. Politics is a strong and slow boring of hard boards. It takes both passion and perspective. Certainly all historical experience confirms the truth that humankind would not have attained the possible unless time and again it has reached for the impossible. All human activity involving more than one person is political. And beware, Django, Python, free software in general, these are impossible things. Anyone who's ever tried to explain free software to their parents knows what I'm talking about. The idea of working collaboratively on software to make something that we can all use and understand, that runs so completely against all Western societal norms. It's important to remember that. And yet, it does work. It produces world-class software. It makes software accessible to audiences who wouldn't previously have had access. And it allows a worldwide community to develop, sharing knowledge and experience, making the world a better place. I am speaking to part of that community today. It's taken 30 years of effort, but the benefits of that effort are now undeniable. I have benefited personally from being part of a large and successful project like Django. I'd like to see similar success with Beware. Only time will tell if that happens. Both of these projects wouldn't have been possible, or at least would have been significantly different if it wasn't for the groundwork laid out by Python and the Python community. I am very keen to make sure that that groundwork doesn't go away. It's taken 25 years to get where we are today, and it would be a shame to have to develop it all over again simply because we didn't pay attention to the way the world is changing around us and plan for how tomorrow's Python will fit into the future that is evolving around us. And as Python, the language, grows and adapts, we need to make sure that our community grows and adapts as well. This awesome language we know and love would be nothing without the community of people behind it. And as that community grows, I want to see it go from strength to strength. Thank you very much.
Thank you, Russell, so much for the talk. Do you take any questions?
I will take questions outside. Come and see me.
Okay, so thank you very much. This has been a very inspirational talk. Questions outside. So yeah, that's about it. So our next talk is going to be by Tomasz Wozniak from STX Next in 5 to 10 minutes. Is the sound coming from your laptop?
It maybe was.
I think it was.
Possibly. I'm sorry about that. I didn't realize
it doesn't matter.
Yeah, all right.
Yeah. Wow, that's a very nice talk.
No, thank you.
Very nice talk.
Hope I set some cat amongst pigeons and...
Did you do this before?
Sorry?
Did you do this?
That's a new one. That's the first one I've done now. Bits of it I've been from elsewhere, but yeah.
Very good. Very good.
All right. Hello, you're next up. I will get out of your way. Hang on, where are we? Let's take that from there. Here we go. How is it possible it gets that tight in a knot in so little time?
Cables. Hi. Okay, I would like to test.
Yes. Check.
I will need one of these because I will present live coding and it will be
Right.
useful.
Okay. Right. So I need to figure out because two of them. Okay. So a very important thing. Make sure the sound is off.
Yeah.
when you connect it.
No problem.
Yeah. So that's about it.
Can we test if
Oh, this is still working. Can you just?
where is the button to turn on? Here. Okay, you will just turn it on.
Do you want questions?
Yeah, we can. I believe it's only 40 minutes. I'm not sure if I can make it with questions. Yeah?
40 minutes.
40 minutes.
Yeah. Okay.
So probably not.
So what you can do, but I have no idea how to turn this mic. No, it's okay. Now it's
Now it's on. Right, so which one will work? Both?
both will work.
Okay. So.
The questions, you know how it works?
Yeah, but just need to read from here or here.
What you can do is like you can go on, work on your coding, pay attention a bit with your left eye. The full questions are usually going to be uploaded and push them forward. So if you notice at any point that you want to answer a certain question, you can just go in and start answering it, or maybe you can, like do it in real time. The answer is going to pick up on anything that you are answering. He's going to either highlight it or dismiss it, and we also have a filtering thing going on.
Probably I will leave it at the end because I need to say everything in 40 minutes. Short.
Sure. Yeah. Sure.
Choose what questions you want.
Okay, great.
So left one is the timer, right one is the questions. You can tell Victor if you want questions to be like aggressive, filtering of the questions. If you want them to be aggressive, only like very important questions. So you can tell him right now. And
Can we test this if the clone works? I would like to clone this page to have the same here, like
mirroring.
Mirroring,
Okay.
yeah.
So this should work out of the box. So it's a mirror. Mirror. Okay. So this is how his name would look. Definitely. Victor, what's the music? This is how it's going to look like definitely. So,
Okay.
because I see that the resolution is
okay.
squeezed out.
So it should, well, if I change.
Hi everyone, Luca. I just finished giving my keynote at PyCon Balkan, first ever. Can't believe what I...
Okay, guys, we're gonna start in 5 minutes. We're starting in 3 minutes. Okay, guys, a quick reminder. So, I don't know if you noticed, but yesterday I've been turning off the screens when no questions are allowed. So if you see the screens on at any point, that means that questions are allowed and you can actually post questions via your cell phones. That's it. Okay, we're gonna start in 30 seconds. So, our next talk for the day is going to be Tomasz Wozniak from Next STX. He's going to do actually live coding, which is very brave. And wish him luck and give him a big round of applause.
Okay, hello everybody. I'm Tomasz Wozniak. I'm working STX Next. I'm Python developer, and our client is Optimat. They are managing a media trading video in UK and Ireland, and we built for them the Copy Central, which is the clearance media platform especially for UK. And among others, we handle complex workflow, a large file uploads, and the last point is very important because we built 24 hours end-to-end tests, and this is still growing. And today I will try to say something about behave scaling. So why it takes so long? This is the main question I will try to answer. Basically, end-to-end tests are slow because there are many layers that communicate each other, especially browser and WebDriver. And the second point is a very large number of scenarios. I would like to extend this first because, yeah, do we really need this? Sometimes tests are slow because basically people don't know how to use it properly, and there are a few tips, like maybe it's not a good idea to put more complexity into your test framework and try to think about parallel run. Maybe there is a place for improvement before you put your mind on parallel. So few points. Wait for event, don't use time sleep, use reasonable scenario outlines. In BDD, each example will be executed like a separate scenario. Write non-GUI BDD test, maybe not always using Selenium is necessary. Maybe you could use just BDD without Selenium. And there are a lot of more points that you should give a try before you think about parallel run. But if let's assume that you did everything you think you could, and we think we did, 24 hours of end-to-end testing is crazy time, and this is something that we wanted to avoid. And I will show you today an example based on technology stack on presentation. Okay. It's of course Python, Behave framework written in Python. On today examples I use of course Python 3, Selenium and WebDriver. Of course we will need a browser and Docker as tool which will help us make it happen. So before I start, I should say something about behavior-driven development. And apart from this great advantage of it, like writing tests before functionality, we got the closed structure like on this slide. This is the example of feature file. We can see feature which contains scenario. There can be multiple scenario, and scenario contains steps. This help us, and this give us actually to manage this and divide it in individual units, which will be helpful in splitting it into different processes. But before everything, we should assume that we will prepare properly to scaling test. The first point is that we should have scalable environment which we're going to test. It will be really bad if we ends up when we put some time on scaling our test, but we will end up with our application will be basically the bottleneck. So if we want to scale test, we should be able to scale our platform as well. The second point is independent scenarios, which means that each scenario should be independent. So each scenario cannot rely on different one. We should use separated data because we wouldn't have enough control of order of executing scenarios. So it means that we should treat each scenario like individual unit can be executed in any time. And the last point is important in our case. This is the fixtures. I believe lots of you are using fixtures in your tests. And usually end-to-end tests or Selenium tests are executed on some working system like UAT. So it's really bad if tests are failing because of broken data. So as example, we use users and for example, we have client which clicking on the system and change user password, and our tests are failing in the middle because this password is not correct. So we built some kind of tests for tests, and we executed before each run on end-to-end tests. Basically, we use Python request library. We send a bunch of requests to our platform, and we validating if all data is properly. It takes around 30 seconds, and thanks to that, we are sure that all fixtures that we are going to use are set up. Okay, so I divided this whole test framework into 3 parts. Each of this should be scalable. First is browser, second is Selenium WebDriver, which will control the browser, and Python environment, which will control the rest. So each point should be individually scalable. And like I mentioned before, Docker will help us to make it happen. This is a concept of scaling Selenium browsers. This is the diagram from official documentation. We can see 3 nodes with Firefox. These are basically the browser, and Selenium Hub is kind of load balancer. So we use one endpoint from our Python behave framework, and we call only Selenium Hub, and Selenium Hub will redirect all traffic to each node. So this is kind of diagram. I seen this specification built on physical machines, so it sounds like wasting resources. And this is something that we are going to build on Docker containers. So when I said Docker containers, some of you probably think about Docker Compose file. This is something which will help us to spin up everything in one configuration. And this is something what actually I pulled from Selenium Docker registry. So this is exactly copy-paste from documentation. And there are available 2 browsers. One is Firefox, second is Chrome. I use only one for this presentation because I would like to have one browser connected with one worker. Probably some of you are thinking, how about Edge or Safari? This is not Dockerized. And if you really need this browser, probably you need to consider some cloud solutions like Browser Stack or something like this, but it will be really expensive. Let's try it. So I will execute this Docker Compose file. It is visible? Should. Okay. So at the bottom you can see 2 containers working, and this is first is Docker Hub, Selenium Hub, and secondary is just Firefox. And I will go to Selenium GUI, and we can see there is one browser ready to be used. So let's scale it. I have added 8 Firefoxes. And we can see 8 containers are running on the bottom. And I will refresh the page again. And yeah, we got 8 ready Firefox on my laptop. And basically that's it. That I just resolved 2 of 3 problems here. And actually, I didn't write any code. I just pulled the configuration from Selenium documentation. The third one is more tricky because currently in Behave, there is no feature like scaling or run in parallel. So we need to figure out something our custom. But before we go with that, we should just think about the main problem, how we are going to divide scenarios to individual worker, to individual process. So the first idea was that let's maybe count steps, and based on that, we will assume that if one scenario has 5 steps, it will execute with 5 units. And we end up with something like this. It was really naive because each step is different. Each step can take a different time. Of course, each step has different goal to achieve. So in this example, we got worker 2 that finished its job in the middle. And basically because that we assign these scenarios to worker 2 by at the beginning, we cannot let him work later, so we are wasting resources here. This assumption was really naive. So the secondary approach that was, because Behave framework allow us to control logic before and after scenarios. Basically there are hooks. We can execute some code before, after, or before everything and after everything. So maybe we could create some microservice where we could store timings, the real timings. We can calculate time when we started and the end, and based on that we can calculate scenarios based on real times, and it should be something like this. It doesn't matter how many scenarios are in one worker, but we rely only on real timings. But what possibly could go wrong here? The retry. So what is retry actually? This is not something explicitly implemented in Behave, but it's really helpful to keep test in positive state, let's say, because it's very often when Selenium fail on some unexpected scenarios, on randomly failing, people saying that. It's actually not true. Usually it's because people don't use it properly, don't waiting for events or expecting something before it appears. And this retry can a little bit help that keep this build in healthy state. I mean, after retry, Selenium can find this missing element and everything can be fine. But this is only a workaround. This is not a solution. But retries are useful to keeping everything in real state. We would like to avoid false negative because it makes people that people don't treat it seriously. If people see red build every single day, people don't look at it in the file. So we came up with the first solution, and this is something like we use right now. So we drop assigning scenarios at the beginning. We take all names from repository, and we put this in queue server, and then we pull scenarios from queue server and we executing until last message. So thanks to that key, all workers will work until the last message. So it should be something like this. It doesn't matter how many workers we have. It's up to us actually we can add it in the middle of the run or remove it. Also, we don't have to maintain workers on one machine, and can be split into even in Amazon container service. So scenarios will wait for execution, and workers will be pulling this from the queue. But for this solution, we will need more containers. And as example, I found a ready image of Docker RabbitMQ. This is something that I can pull like Selenium images. This is the broker which will handle messages, and our one message will be simply scenario name. But for we got broker and we will need worker, and I choose Celery, which is a really cool tool. Probably all of you are familiar with it for asynchronizing task executing. And this is the sample of Dockerify. This is the first code that I've written here on the slide. We can observe only a few lines. Basically, it's installing requirements and run Celery worker. What is worth to mention that I changed concurrency to 1, because in default it depends of your threads in your CPU. It's 4 or 6, but I would like to show you that one worker works with one browser. So, okay, let me show you this. I stopped previously created containers. I will switch branch. So basically, I added new sections in Docker Compose. I will show you it right now. And we can see there are a few containers working, 2 previously created, and 2 new. One is RabbitMQ and one is a worker, like expected. And I'm going to explain what I'm going to do right now. So this is my Docker Compose with extra sections, RabbitMQ and worker. This is a simple bash file which will take all scenario names from our Behave framework and put it in RabbitMQ queue. And I created 2 sample of feature files. Here we can see 3 scenarios, and here there are 4. This one, deleting user will fail. This is expected because I would like to show you the output of it. And this is an example of scenario outline. This is something that I mentioned before. Each example of this will be executed as individual scenarios. So we are going to divide this an outline to separate run as well. So I expect to run around 8, it should be 8 tests. Let me show you logs on this console. I believe it's not real visible, but I will show you something better later. So let me run a test right now. And it will print out scenario names. We can see the outlines was divided into 2. Separated scenarios, and we can see one worker actually right now is working, and the average time of each scenario is around 10 seconds, so we would need wait around more than 1 minute. Meantime, we can look on the statistics. We can see the high consuming memory is of course Firefox. I have calculated this on real system, and the average is between 500 max to 700. So quite a lot, but this is still something to be really scalable in cloud solution like Amazon. Okay, so let's have a look about on this test result. There are a few passed. We are waiting for this failure, which is supposed to be at the end. Almost there. Yeah. And we got this failure. It looks like that. This is the only log, so this is not good to read right now. Yeah, let me scale right now our workers and browser. Oops. Okay, so I need an additional scale parameter. So here we can see scale Firefox, scale worker. Maybe, oops. Maybe it's not visible. Maybe now it's better. Okay. So at the bottom, we should see Docker statistic. We running 16 containers. And we'll execute test again. Because I have 8 workers and 8 Firefoxes, I expect the result maximum 15 seconds, maybe 20. Because there is a little delay printing out scenario names here, but it can be limited. I mean, we don't need to print out it in production, so this is only for presentation. We can see in our Docker logging that all workers are working and all results we got immediately, apart from the last one. Yeah, it was around 20 seconds, let's say. Yeah, 20 seconds. So I actually presented you the scaling from 80 seconds to 20 seconds. So it's not that just like divide for threads, because there are always some delays. Okay, but like you see, reading of this is not really cool. I would like to report it somehow and keep it as Jenkins artifact. So for reporting, we use Allure. This is something supported in Beehive. This is actually separate Python package. We need to install it and add one parameter to Beehive run. And basically, it will generate this kind of JSONs in your home directory, in your repository directory. And after one command, it will it will redirect us to this kind of GUI. This is the HTML report. It can be assigned to Jenkins, and it will grab everything into one report. It doesn't matter how many processes are we using. It will be presented like one single run. And we can see 2 feature files here, and there are one feature file contains multiple scenarios, and here we can see steps and time of execution of each step. Here is the red which failed, and we can see bomb icon here. It means that the test is flaky, so we have more than one result here, and this is an example of retry. So first retry just was passed, but secondary will fail, and it marked it as red with bomb icon. It means that we should something do with that. It's not stable test. Okay, but this is only reporting tool. We would need something more because there are a lot of things happening in the background. So I would like to see what exactly going on there if something is not right. So we have 2 options, and this is probably we get more, but this is totally enough. One is RabbitMQ control. This is command available in RabbitMQ container. We can monitor queues there, basically, and we can connect it to our dashboard or anything. And the first one from the list is celery flower. This is something that I'm going to present to you right now. So I stopped all containers. Logging will finish. And let me change branch to step 3. And we'll re-execute our containers. and go to Celery Flower GUI. It looks like this. We have to wait for our workers are connected in broker. So I will keep refreshing. Loading. Oops, let me try workers are there. Yeah, we got 8 workers waiting for our task, and this is the tool which can be useful for monitoring. I'm going to execute test again. We don't need logging here because we will look into Flower. So I executed 8 tests, and we can see this is immediately updated. Each workers take 1 message. All are processing in the same time. And yeah, in this GUI you can see the actual scenario names. When I refresh it, we should see some success and 1 will fail. The result pass means that test pass, of course, but 1 with fail will not have the result because it's not possible to fail with result in Celery. So what we would need here is something go wrong. Of course, traceback, it's here. Full traceback and actual scenario which failed. And maybe it would be useful to attach some screen, but it's not implemented yet here. What next we have here, we can use this monitor it's actually something ready to present on our screen, but probably we won't see anything because it will be immediately start here, so we'll execute test again. So we got 16 messages here, so we should see some graphs soon. So this graphs present a succeeded task, failed task, and queue task. Queue task just means that we have more messages than workers, and this is something which could be used for monitoring how many times we need to spend on test, or what is the ATA for this. Yeah, 1 failed, it's correct. A secondary failed because I ran it twice, basically. Okay. So summary, in our platform we reduce time to 1 hour, and we use 32 parallel processes, and it cost us only for browsers, of course, workers and web drivers in AWS 50 cents. Yeah, so quite cheap. We execute production smoke testing on Behave. Thanks to time executing, we can do it faster and validate it after each release. And we agreed that no test, no match, and it's related with our Behave repository and Python, which we run on our platform. So because that we are able to validate each change in 1 hour, it can be improved. But in our case, the system is bottleneck. So the 1 hour is totally acceptable here, because basically we can validate the whole workflow by that. So I'd like to repeat the keyword, scaling. You should be able to scale your application if you'd like to scale your test. And at the end, I'd like to share 2 pro tips. So the first is find top 5 longest scenarios and fix them. Scaling won't help you if you end up with the last scenario will be executing 30 minutes or something like that. I will suggest to keep maximum 10 minutes. Maybe it's still too many time, but 10 minutes is totally sufficient for us, and this is something that even if the last scenario will be executed in at the end, this is only 10 minutes. Yeah. And the second tip is to find top most often repeated tests. It will be visible in our as bump icon, and fix them. Repetition of tasks or scenarios is only workaround. It's not solution. And that's it. Thank you.
Okay, works. Thank you very much, Tomasz. You have 15 more minutes if you want to answer some questions.
Yep. So the first from top, have you tried also other solutions than Selenium Hub, Selenoid? I have not, so cannot say anything. We can talk about it later afterwards, so I can resolve it. Maybe I will try. Second question is, have you tried wrapper Selenium like Splitter or even better PyTest Splinter? No, I have not as well. I invite authors of these comments after this talk. Maybe we can talk about it. How did you solve the timeout problem, especially in cases where you cannot use retry, like creation of deletion of an object? I'm not sure if this is timeout related with browser, because the timeout of browser can be set on Selenium itself, and there's an API, you can control it. There is a known problem that sometimes browser hangs without any response. This is something that we also manage, and we basically kill browsers and we retrying test them. But I'm not sure if I understand this like creation of deletion of object. And this, I mean, probably it's related with long running of applications, something like that. So if yes, I will say...
if it's a question from the audience, maybe someone could clarify it.
Maybe someone can clarify.
Raise your hand and I can give you the mic. Or maybe it's from the live stream.
Okay, so basically, like I presented on slides, we're trying to wait for events, not for, we don't use timeouts, so it will wait for event. If system is loading too long, we basically fail because we expect it like to be failed. Yeah. Why introducing another level of abstraction with behave when Python code can do the same with PyTest with more flexibility? It's all because you can split it on multiple containers, which means it can be executed in multiple machines. So if you use AWS, you can use ACS service and keep it and scale it when you need. So yeah, this is another complexity abstraction. I agree with that, but it has some advantages for us.
Okay. Thank you very much, Tomasz, for the talk.
Thank you.
So we have a 20-minute coffee break, and after that we pick up with Lukasz Kubisz from Kiwi.com. All right.
Yeah. Thank you. Thank you. You too. Sure. Yeah. Yeah. Okay. Okay. So tell me what I should say. Okay.
Okay. Pap. Se vratimo nazad na onaj old school način sa njima, jer ovo je šitić. you.